Thank you for being here this morning. My name is Randy Bias. I am a vice president at EMC, now DELL EMC. I was one of the founders of the OpenStack movement. Some of you hopefully know me. I was hoping to do something a little bit different this morning and talk about something close to my heart, which is the pets versus cattle analogy. Before I do that, though, I was always told I should have some kind of icebreaker. And I'm horrible at telling jokes. The only one I know by heart takes 10 minutes, and we don't have 10 minutes. So I thought I'd show you a picture. This is me and my new baby, Leah Kay. I know, thank you. I do look good there. As you can see, this is us again in the living room, and she's very, very happy baby. This is us in a recent movie that we did. I don't think she carries off the monster suit very well, but I think I did pretty well with the pigtails. So what I want to do is I want to tell you a little bit of a story about pets versus cattle and sort of help give you some perspective, because I found that sometimes people get a little bit confused about where it came from, what it was about, why it exists, and they like to extend it in ways that I sometimes find doesn't make sense, and that I hope will help you in your journey through cloud. So I'm not going to talk so much about OpenStack. You can find me afterwards. I'm happy to talk about OpenStack lots. I have historically been one of its biggest proponents and also one of its biggest critics, so I'll give you some honest feedback if you're looking for it, but that's not what we're going to do today. So in the early days of cloud, the challenge was that it was very hard to explain. It was very hard to explain it quickly and succinctly and to really nail it into somebody's head quickly. So what happened a lot was people said, hey, cloud is Amazon Web Services. It's about buying something online. It's about outsourcing. Except what we've seen over time is that it really wasn't. And so I struggled, right? I was giving lots of presentations, and I was trying to help people understand, what to do. What's my 30-second elevator pitch? How do I just tell somebody going down the elevator what cloud really is in a way that kind of gets back in the deep recesses of their mind? Because if it was just outsourcing, it didn't make any sense. So I went looking for a certain amount of inspiration. I said, I need to boil this thing down. And I came across this gentleman, Bill Baker, who had a great presentation called Scaling SQL Server. And it talked about, it had a particular way that he would describe scale out versus scale up. And I thought that was something that I would like to steal. And Pablo Picasso, sorry, Banksy, sorry, I said that great artists imitate, or good artists imitate, bad artists imitate, great artists steal. So I stole. And people stole it from me, and then you had a meme. And when I went about coming up with this pets versus cattle thing, I had no idea that it would take off and that suddenly everybody would be using it. I mean, how many people here have heard pets versus cattle? So that's crazy, right? That's really crazy. So I didn't know that would happen. What I did know is that I need to be able to tell the next guy in a suit, apologies to anybody in a suit, that what the deal was. And I could maybe have a long, involved conversation with an engineer about cloud, but that's not what's going to happen in most business contexts. So you got pets, you got cattle. How does this help explain why cloud is different? Well, there's a hint, right? Pets are unique. And this is a really important thing to keep in mind whenever you're talking about pets versus cattle. So for the last, 4.5-ish years, this is my exact elevator pitch. I've said this so many times that it's a little ridiculous. The only difference is that I usually use Bob the mail server instead of Frodo, but that wasn't very cool, so I changed it. But I'll let you read it for a second. This is what has spilled out of my mouth hundreds and hundreds and hundreds of times in a meeting when I come across somebody who doesn't really get cloud, and they're really thinking about it as sort of an outsourcing model, or they're thinking about it as a pay-as-you-go model, or whatever it is. And the reason that it's important to pitch it like this or something in this vicinity is that it helps reinforce the story about uniqueness, which I'm going to go into a little bit more soon. So another thing, and if you've ever seen my presentations, some of these slides will look familiar, is that the way I think about sort of the old way, the pets way versus the cattle way, this is another way I sort of describe it, and this is what I call assembly line IT, right? This is the way that we've done things in the past, the old way. And think about assembly line IT, which is sometimes called Mode 1 or second platform or legacy or enterprise computing, whatever you want, is that it's very much about all these specialists on the assembly line, right? Each one has a task. The security guys, the database guys, the server guys, the Linux guys, the Unix guys, the Windows guys, the app guys, everybody's got a position on the team. And that team basically goes, and when an app comes into the data center, goes through the process of gathering requirements for that application, and then that application runs on down the assembly line, and out the other end comes this, basically customized application running on its own siloed infrastructure. Sound familiar? Right? So the thing about this is that it's very similar to the way that we build cars. If you go back even to the 70s, as recently as the 70s, this is the way we built cars. And if you look at a 70s Barracuda coming off the line, there would be all these little imperfections. The decals were slightly differently, and the doors were not exactly fit. And the reason is because you're basically building a bespoke car in mass production. That's the way the IT has been done historically. And this is what I mean by every server's a pet, right? They're all unique. They're all indispensable. If Frodo the mail server goes down, CEO can't get his email, and it's the end of the world. Oh my gosh, everybody stop what they're doing to fix it, right? So examples of that, mainframes, pairs of load balancers. I'm sure you've noticed that your data centers are like pairs of everything, right? It's pairs at the top, it's pairs at the bottom, pairs of load balancers, pairs of switches, pairs of firewalls, pairs. So that pair really is more like a single server, or at least that's what it's intended to be. Right? It's like two servers that sort of try to act as one. And one thing that's important about cattle is that, as you probably noticed, a herd of cattle is not two. It is quite a few more than two. So this is the new way. This is what Google and Amazon and Facebook and Twitter and even Microsoft Live have all taught us, which is the Robotics Factory model of IT. You don't have these specialists on the assembly line anymore. What you've got is the people who know how to build the robotics factory, the people who know how to build the robots and program them, and the people who do QA and make sure that the whole thing doesn't come apart at the seams. And you'll notice that every car that comes out of that factory looks exactly like the car before it. Right? And so that's really what we're moving to. That's the model we're moving to. That's cloud computing. That's why the pets versus cattle thing is so important. Right, is that we have to basically make it clear to somebody who's asking that all the effort that we have put historically in the past into making sure that one server never fails. Like it's got to have 5 nines of uptime and a fiber channel SAN and 2 switches and all of that is basically getting thrown out. If you go into a Google data center, there's one top of rack switch and any rack can fail. Right, it's a gigantic herd of cattle. So this is just a summary. I'll let you kind of scan through it and kind of compare kind of the old way versus the new way for a second. I think most people get this at this point, so I'm not really expecting this to be news flash to this crowd. What I am trying to do is basically reinforce the difference between your puppy dog and the steak you had for lunch, with full apologies to all the vegans in the crowd. So, one of the things that's interesting that Google taught us is that failures not only do happen, but will happen and will happen regularly. And when you get to a massive scale, they're going to happen all the time. It's just constant. So if you build a system that tries to pretend that you will have zero downtime, right? Like a pair of HA load balancers is basically an attempt to build a 100% uptime system, right? If both load balancers fail, there is no fallback. There is no plan. It is all over. Boom, the whole thing's down, right? So it works great until it doesn't, and then you're out. So the way that the web scale guys taught us is that they know that's going to happen. That pair of load balancers, that server, that pair of NFS servers, all of these things are going to fail at some point. So instead of pretending like they're not, what we're going to do is we're going to assume that they will, and we're going to build the system and the applications to take advantage of that. For the system, it means we stop needing two of everything. We have one of everything. For the applications, it means we design them to route around failures, to detect actual problems in the underlying infrastructure, and then to basically do the right thing when bad things happen. So this is a big deal because the aha moment for me on pets versus cattle is that we moved to this model where instead of having a 5.9 infrastructure that would have 3.9 applications on it, and we would pretend that we were actually hitting 5.9s, we actually write our applications to be 4 or 5.9s, and then we can run our infrastructure to 2.5 nines. I mean, that's what Amazon is. They give you a 2.5 9 uptime guarantee for the most part. And that's great. That responsibility shift means a lot of things. It means that the infrastructure can be cheap. It means that we can move the business value and the learning and the education for our IT teams to where it really belongs, at the application layer, right? Because infrastructure is non-differentiating. So the problem with taking pets versus cattle and doing anything else with it, right, and talking about it in any other way, is that 30-second elevator pitch explaining how a pet is different from cattle, the old way versus the new way, can get really muddy. I'm going to show you what I mean. So recently, the Kubernetes guys, and yes, I am about to throw Google under the bus, came up with this new feature called pet sets that goes into Kubernetes that allows for stateful applications to basically be managed well by Kubernetes. And basically, the underlying story they're telling here is that pets are stateful, and cattle are stateless and ephemeral. And now Kubernetes can support both because they've got this thing called pet sets, which does this wonderful stuff. And they gave some great examples of things that are now supported. So Cassandra, Kafka, and MongoDB. All of these, of course, are cattle systems, right? They're all distributed, scale out, multi-master, N replication systems, right? So there is no indispensable and unique Cassandra node. You notice they didn't list Hadoop, which sometimes has a single name server, right? So if you look at the world's biggest stateful system, it's Google, exabytes of data, and it's cattle all the way down. So this idea that cattle are only stateless and ephemeral applications and never stateful is bunk. And that should be really obvious by now. And the problem is that when somebody comes along and tries to take the pets versus cattle meme and suddenly tries to make it be about stateful and stateless applications, now it means something else. Like, I'm cool. I think it makes sense to talk about stateful versus stateless applications in the context of containers. I get it, right? People don't understand containers well. They're trying to figure it out. The whole thing doesn't make a lot of sense to them. But the reality is that, well, taking aside the fact that containers do fine with stateful applications, the reality is it's better to create a new analogy instead of overloading an old one, right? I mean, how many people are sick of having to deal with just explaining cloud in general because it's complicated and the damn word's overloaded? I didn't get any hands? Okay, hybrid cloud. Okay, we could keep going, right? So I guess I'm a stickler for terminology and for taking something that makes sense, and you can extend it a little bit, but like trying to make it mean multiple things actually causes a problem because we're all trying to communicate with each other and with the marketplace and with our internal customers and external customers. And when we take a lot of liberties, it just makes everything very, very messy. So. I think that's pretty much it. If you want to get the maximum value from pets versus cattle, I would like you to pitch it my way. You're all independent free thinkers. You do it your way. If you don't like my way, that's fine. But this is my attempt to get you to think about it my way. And to hold to account people who are thinking about it a different way, because we need that analogy. It's still valuable describing it to people. I still, as many hands as went up in here, I still run into rooms of people who need it at the outset. Like, I'll give you an example. I went into Port Authority of Singapore a few months back, and these guys are amazing, right? It's the world's largest transshipping for real containers, the big metal boxes, right? They ship, thousands of those in and out of the port all the time. They are transferring them between ships so that they can actually get the cleanest or the most efficient routes. I mean, it looks a lot like a big switch, a big network switch, where the packets are these big metal boxes. And these guys, basically destroyed a lot of the other ports in like the 1970s because they brought in technology to apply to transshipping for the first time and built this wholly automated technology, and Port of Singapore became this major player on the world stage. So I'm sitting there talking to these guys, and they barely know anything about cloud. I mean, they're using Oracle, and it's really old school stuff. It was state of the art in the 70s. It's 40, 50, 60 years behind now. And I'm talking to them, and I realized I need to have the conversation from 6 years ago. I need to have the 2010 conversation. And I brought out pets versus cattle, and they're like, oh, we get it. Like, we have the opportunity to basically leapfrog over and rethink our entire IT stack and do what we did the first time, but again. And we went in the space of 5 minutes from a conversation of why should you do this to a conversation of how do we do this? How do we adopt DevOps? How do we move to cloud? How do we think about this? And that's a big deal, right? I could have spent that whole hour session with those guys just educating them, and instead within the first 5-10 minutes, I had them flipped over onto the how do I do this? So, respect the meme, right? There's some resources here. This is already up on slideshare.net. Randy Bias, hard to miss. And I guess since Chris was taking some questions, and I've blown through this fairly quickly, that I could take questions if you have some, or I could take questions about OpenStack. Honest questions. Honest feedback to your honest questions. Anyone? This gentleman over here? The headsets is a feature in Kubernetes, and it basically is a feature in their container management system that allows you to more gracefully handle stateful applications. So it will do things like sequence up master-slave arrangements. It knows something about, it doesn't treat, so if you, typically, for most cattle-based systems, you've got an array of web servers, for example, and they're all completely interchangeable. And you've got a way to basically spin them all up, and you don't care what sequence they come in or out, right? When they come up and they register with the load balancing service or the discovery service or whatever, then they're in the array. And what PetSets does is it gives you some nice features around kind of sequencing things up. So if you had like a master-slave pair or something like that, then you can sequence one up before the other. You can have some dependencies there, but it's not what I would call sophisticated enough to do like Oracle rack, spin-ups and things like that. I'd say if there are three canonical examples are Cassandra, Kafka, and MongoDB that, if you can do Oracle RAC, you would say Oracle RAC.
Cool, thank you.
You're welcome. More questions? Oh, not Sean.
Yeah, Sean. So what's new that we can expect from DELL EMC at Barcelona? It's not supposed to be a mean question. I'm trying to help self-promote here.
My pause has nothing to do with that question. It's that, anyway, I'll tell you personally afterwards.
Okay. All right, now I'm in trouble.
So we're going to be flying the flag on Neutrino, which was our hardware-based appliance that is a turnkey OpenStack solution, which is pretty amazing in my opinion. It has a lot of the cloud scaling technology, which was my company, installed in it. It takes OpenStack and we Dockerize the whole thing and then put a lightweight management framework around it so that we can dynamically put OpenStack on a stack of hardware, and we can do it, whether it's the control plane or elements of the data plane. We can take units in and out of service and so on. Probably the coolest thing about Neutrino is that it's not OpenStack specific. It's meant to handle multiple services, and the first service is OpenStack. Later on, we'll be doing VMware Photon, Hadoop, and possibly containers as a service, all running directly on the bare metal, kind of side by side. So that's what we'll be showcasing. It'll mostly be OpenStack at the summit, but there'll be a live system there. Man, it was really hard to get a live system to Spain. I had to really put the screws to people, but they came through, and so that'll be there, and people will be able to play at the system directly, no demo this time, and We have 8 neutrino abstracts presentations that we're giving, I think, at the summit. So we're showing up pretty strong. But definitely the DELL EMC strategy is around appliances for OpenStack at the moment.
I had a quick question in regards to pets versus cattle, and it pertains specifically to OpenStack.
Yeah.
There's a number of agents in the OpenStack reference architectures that are actually not supposed to be run as cattle. Can you speak to any of those? Or what the plan is, right? Because I feel like if OpenStack, if we're trying to pitch that to our customers, and our services aren't completely cattle, I feel like we're not eating our own dog food there.
Yeah, so so the question, I think everybody heard the question, right? So there are parts of OpenStack that are not very cattle architected. And it's a little disappointing 6 years on that that's the case. I can't speak to when that's going to get fixed. I mean, you guys all know what's great and what's not great about OpenStack. One of the things that's not great is that, it's a little bit of the, 5, 6, 7, 2,000 chefs around one, soup, kind of making it together. So things go very slow in terms of progress. What I can tell you is that, if you look at products, not OpenStack itself, a lot of the people who have built products have solved these problems. So the cloud scaling product, for example, ran an N-way active, however many you want, control plane for every single component in OpenStack, including the schedulers and the APIs and the databases. We ran it up to 7 ways for Walmart, and the architecture should have gone to 31. And we could discuss why that. So we did some stuff to kind of fix OpenStack so we'd do that. What I have seen a lot with OpenStack is that because it's a little bit of a kind of a science project, that you can put it together in the wrong way and you can put it together in the right way. One of the nice things about going to a company that's got an opinionated stack is that hopefully they did it the right way. If you put it together yourself, you're going to have to figure out the right way. But what I have seen is some people who've got products do it the wrong way. So I'll give you an example. In the early days, this is not as true anymore, but in the early days, everybody decided to throw Linux HA at the problem. So you would basically just do an HA failover pair for components. And so one of the components, when you're using the single host mode for networking in Nova Network before Neutron, was that you would run all the network packets through a Linux box, running Linux HA to a second box. So when you did failover, for 60 seconds while Linux HA did the failover, there was no network traffic across your entire cloud, right? And so that kind of thinking is a little bit rife in some of the early products. I think a lot of that's been sanded down now, but I'd say that you should probably just try to go to a vendor that, I don't mean to sound harsh, but has a clue. And I think you can get a fully cattle version of OpenStack if you look around for it. Project, man, project.
Yeah, well, I didn't want him to just get it and then finish my question. So this whole discussion of pet versus cattle, I think sometimes it gives the impression that the infrastructure, which is the hardware and the operating system and some other middleware, is no longer important. It can just die and you just move over. At the end of the day, you need to be able to have some kind of fault management in the infrastructure. I mean,
What
yes,
management?
maybe fault management. In
Fault
other words,
management.
I mean, you're talking about HA, one aspect of cloud, and you're saying that the infrastructure can now be a pet. The reality is you always need to be able to detect a failure and let the
In the
application
infrastructure
know.
layer.
In the infrastructure layer.
Why?
Especially in a virtualized environment.
Why?
Because the application does not have visibility into a lot of the hardware components.
It doesn't need to
because it's
when they're-
virtualized.
it doesn't need to because when any of the virtual machines or the applications that's running inside of a particular virtual machine starts to have a problem, the application is aware of that and can take immediate action.
But how does the application switch over or fall over to
Well, first of all,
the end-to-one?
Running failover is like the old way of thinking about things. You don't run failover, you run multi-master and you run active. So you've got, say, 10 systems that are doing the same thing. You lose one of them and you're down 10% capacity. So if you want N+1 or N+2 and you have, you need 10 systems of capacity, you're running 11 or 12 usually. And as one goes down, you spin up another one. Now, so one of the things that I've seen, and I think kind of at the heart of your question is like, well, shouldn't the infrastructure be smart? Well, the problem is that, taking aside whether that's the old way or not, there's a whole bunch of issues with that in the future, right? First of all, none of the web scale guys do that. Google doesn't do that in a system anywhere. And part of the reason is that you can't have that logic in two places. When you put it in the application layer, you can no longer put it in the infrastructure layer, or you create race conditions or other kinds of issues that will arise. So for example, say I'm running an application. I saw this in real life on CloudStack in the early days, pre-OpenStack. If you're running an application that manages itself, and it's running on top of infrastructure that looks for faults. They're both looking for a VM to fail, right? The application knows which 10 VMs it's using. The infrastructure has no freaking idea which VMs belong to any application, and there's hundreds or thousands of them. So out of, say, 1,000 VMs, 10 are in use by a particular application, and it knows what the state of its 10 is pretty much immediately. The infrastructure is going around and around and around and around, trying to figure out when anything fails. And in that case, it could take 30 minutes before you'd find a VM. So an application, component of the application, the VM could go down, right? And then it could be replaced, and then the infrastructure could come around and see that VM was down and restart it again. So suddenly you've got another VM. You wind up having duplicates of things in the system that you wouldn't want to. Or even worse, you could take a database that was paired, that was synchronized. It could go down, the application could notice that it was missing a pair or second or third or fourth, and start one up, resynchronize it, and then that fallen database server gets restarted again suddenly, and now it's synchronized how? Like, you really create a lot more problems. You cannot have the business logic for fault recovery in both the infrastructure and the application at the same time, because the logic will simply run into each other.
Yeah, no, I'm not suggesting that, and maybe I'll take it offline with you. I'm just saying for stateful application, everything you've said for stateless, I buy, but for stateful application, if you need to preserve
run Cassandra,
state in
run
the
100
application,
Cassandra servers.
But you need the application to know very quickly. Otherwise,
Cassandra knows it's running triple replicated. Hadoop knows.
Yes,
any disk can fail, any server can fail.
But in a telco application, where milliseconds matter, if you don't have a way of detecting failure very quickly, there's no way you're going to be able to preserve it.
The only thing that will be really blazing fast at detecting that failure will be the application.
We'll talk offline.
Yeah. Any more questions? Okay. Thank you very much.
Thank you, Randy. Also, apart from Dell EMC being the platinum sponsor, Randy is on the steering committee. Randy and Jesse helped us in shortlisting the session talks this afternoon. So give him a big hand. Thank you, Randy.
Thanks.